Hi, today we will see another topic called as a step counter method. So previously in our video we have seen about cascading method. Today's method is also important in designing a pneumatic circuit. So step counter method has its own function. So we read some notes here. Okay, so it is designed to prevent the occurrence of opposite signals for two or more cylinder movement. So normally we have a pneumatic circuit which has more than two cylinders. Okay, so when we have more elements involved, there are possibility of having opposite signals, or we call it as a signal overlap. So we step counter method is actually very effective in preventing the occurrence of opposite signal. Okay, the use of step counting module is very important in step counter circuit. So in step counter method you have a module called counter counting module or step counting module. Okay, so similar like in cascading method we have a group changing valve. In step counter method, counter counting module or step counting module is very important. Okay, so each step counting modulators or module contain two valves, namely pneumatic injected 3 over 2 valve, okay, or 3 over 2 pneumatic valve, and also N valve. So we have two valves involved. Okay, so we continue. So to build a step counter circuit, you need a step counter module that contains 3 over 2 valve and also an N valve. Okay, so you can see here. So this is a step counter module. So you have a 3 over 2 valve and also an N valve. So it is combined together to form a module called step counter module. So step counter module is very important in step counter method. Okay, so it has 6 connections point as shown below. So you have 1, 2, 3, 4, 5 and 6. So you have 6 points, connection points, or we call it as the input. Okay, so you have a warning here. So you must complete the step counter module as shown in the figure below, so that not to be confused with the construction of the step counter circuit. Okay, since it look a bit complicated, but actually it's not. So when you are drawing your step counter circuit, so you need to draw exactly as shown here, okay, in order to avoid confusion. So you can read here, so what are the numbering system represents. So wind direction is actually indicating about compressed air direction. So all the points here, all the inputs here must be connected to its respective or specific port, which we will see in the next slides. Okay, so we will do some demonstration of the step counter method. So you can see here, you can read the description given here. So it's practically saying that, so we are taking into consideration an example of sequence. Okay, so all the pneumatic system, or especially involving cylinders, you have this kind of sequence. So it can be combination, it can be a plus b plus, a minus b minus, or a plus a minus, b plus b minus. So it can have any sequence. Okay, so this sequence is very important in step counter method, so you need to understand that. Okay, so I just read the last line. Okay, examples of sequence above have four movements. So you have four movement: a plus, b plus, b minus, and a minus. So this is a sequence, correct sequence, okay, of the application. Okay, so each sequence will have one step counter module. So meaning here you have four sequence. So you will have a four step counter modules. Okay, so you need to understand that. Okay, so we will see some steps involved. So it's similar to cascading method. So step 1, you write the statement of the problem. So you just like simplify the problem given. Okay, so you just mention it in terms of first cylinder, So you can read here: first cylinder A extends and bring under stamping station where cylinder B is located. Cylinder B then extend and stamp the job. Cylinder A can return back only when cylinder B has fully retracted. So meaning this statement is indicating about the operation of A plus, B minus, A minus. Okay, then second you can draw the positional layout so in a 3D. Okay, so you have a cylinder A movement and cylinder B movement. So this cylinder A is for clamping and cylinder B is for stamping. This is an example. Okay, then you write the represent the control task using notational form. So notational form we have seen in the previous video. Notational form is form like this: A plus, A minus, B plus. So this is what we refer as notational form. Okay, so cylinder A advancing indicating A plus. Okay, cylinder B retracting indicating A minus. So you can have that for any number of cylinder. So normally for your syllabus we will see 2 or 3 cylinders. Okay, meaning A, cylinder B, and also cylinder C. So that's the maximum that we'll have. But in the real application, you can have count various number of cylinders. Okay, so for this example, we only have 2 cylinders A and B. So you have this sequence. This is the sequence that we get from the question. Okay, then we move to step 4. So you draw the displacement step diagram. So you have the displacement step diagram. So you have A plus, B minus, and A minus. So compared to cascading method, you don't have a group changing valve. So you just draw it as it is. Okay, so then you draw displacement time diagram. Okay, similar. So you just replace your x-axis with time. Okay, since time is not mentioned, you just put t1, t2, t3, so until t5. Okay, then we move to step 6. So you analyze the input and output signal. So this step is important because you want to identify what are the input signals that you are needing, and also the output signal that is produced. Okay, so basically we know cylinders normally will be attached with 2 limit switch each cylinder. So you have 2 cylinders, so you have 4 limit switch. Okay, so at home position for cylinder A is A0, the extended position is A1. So for cylinder B, home position is B0 and extended position is B1. And for the output signal, we know forward motion of cylinder A indicating A plus, then you have A minus, B plus, and B minus. Okay, so this is the last step, which is the important step for step counter method. Okay, so step 7 is drawing the power circuit. Okay, so you are drawing the circuit. So you have around 6 steps. So you have 6 steps, step 1 until step 6. You just need to follow it in sequence. First, you need to draw the cylinders and directional control valve attached with the cylinders. Then second, you draw the step counter module for each operation according to sequence from left to right. Okay, meaning if your circuit is starting with sequence A plus, so you first need to draw the first module A plus, then B plus, then B minus, and also A minus. So you must follow the sequence from left to right. Okay, label each module so that you won't get confused. Okay, then the third part, connect input 3 to the respective port of DCB. So you know this is the step counter module. So you have to input 3 here. So this will be connected directly to the directional control valve of the cylinders. Okay, so let's say you have an example here. So let's say you are connecting this input 3 for A plus module, okay, which is the first module. So port 3 is connected to left hand side of DCV cylinder A. So meaning in a normal classical method, so you know which side you need to produce the compressed air to make the cylinder A extends. So you just need to connect this port 3 to that particular port. Okay, then step 4, you have input 4. You need to connect it to previous modules port 6. So you have input 4 here and also input 6. So all the modules will have a port input 4 and also input 6. So what you need to do, you need to connect this input 4 to the previous modules uh, port input 6. So meaning you need to connect it, you just need to draw the line connecting to the previous modules port 6. Okay, then number 5, connect input 1 to previous models port 5. Okay, so you have port 5 here and you have port 1 here. This is from your AND valve and this is from your um, 3 over 2 valve. So port 5. Okay, so you let's say you have module here. So this port is connected to the previous module's port 5. Okay, so once you settle that, so you already covered input 3, input 4, input 5, input 1 and also input 6. Okay, then left input 2. So what you need to connect to input 2, so connect input 2 to input switches or roller switches. So you know, based on the analysis before this, you know you have 4 roller switch or limit switch and also one push button. Okay, all that must be connected to the respective. So you have 4, in this case you have 4 uh, step counter modules. Okay, meaning all the modules will have port 2. So meaning you will have 4 port 2. Okay, port 2. So all the 5 switch must be attached to the respective port 2. Okay, we will see in the example later. Okay, so I will show you. Okay, this is a step counter circuit for 2 cylinders. So you have 2 cylinders, you have 3, you have 4 step counter modules. So this is for operation A plus, B plus, B minus and also A minus. So you can see here, so this is connected. So your input 3 is connected to, for A plus is need to be connected to the left hand side of the DCV cylinder A, and you can see here B plus is connected to the input 3 is connected to DCV and left hand side of uh, cylinder B. Okay, so similarly, okay, for all the other 2 ports, is connected to the respective ports. Okay, then you have uh, input 4 is connected to the previous groups, previous models. So what is that? I think port 3. Okay, so similarly you just need to follow the sequence that mentioned in the previous slide. Okay, so once you already finished that, all the 5 uh, inputs are connected, only will left for input 2. So it is connected to the switches. So you have 5 switches earlier. So for the first sequence you will have additional 1 push button and you have 4 roller switch which is connected. Okay, so this is an example for 2 cylinder application, and you have application for 3 cylinders. So 3 cylinders are very common in your examination, so make sure you understand. So just in this example they forgot to put a label here, so you need to put a label here whether it's indicating A plus or B plus, so that you know where you want to connect. And here they are using 4 over 2 instead of 5 over 2 valve, they are using 4 over 2 valve. Okay, which also possible to be used. And you have 6 modules. So module 1, 2, 3, 4, 5 and 6. So you have 3 cylinders and 3 direction control valve, and you have 6 switches. So here you have switch 1, 2, 3, 4, 5 and 6. Then you have a push button. Okay, here we will see one example. Okay, so this is similar example like in cascading method. So you have a pneumatic actuated drilling machine. So it has two DAC. So cylinder B is to drill and cylinder A is to hold the position. Okay, so you define the motion first. So it has the similar operation just like just now, A plus, B minus and A minus. So meaning you have four step counter modules. Okay, it is arranged from left to right. So A plus, B minus and A minus. So make sure you don't make mistake here, you don't switch the places, then your circuit will be wrong. So once you do that, first step you need to do, so you draw the cylinders with directional control valve. So you make the connection to unactuated position, similar like this. So in this case, you have two cylinders. So you have like this. This is for cylinder A, and this is for cylinder B. Okay, so once you do that, you draw four modules following sequence from left to right. So meaning in the previous sequence it has A plus, B minus and A minus. So you just draw, no need to have a connection first. So once you draw this, you draw four modules accordingly. So follow from A plus, B minus and A minus. So if let's say your application is A plus, A minus, B minus, so this must be here and this must be the other side. Okay, so you just follow. Okay, this is the step 4. That you start to make connection. First you start with connection for input 3. So input 3 is connected, so based on, so you just refer to the sequence. So if the sequence is A plus, so you need to give a compressed air to the left hand side of this direction control valve to make the cylinder to move forward. So you just give the connection here. Okay, this is for A plus. So for B plus, so you need to give your compressed air to the left hand side of the direction control valve. Then so you make the connection here. For B minus, so it must be given to the right hand side of directional control valve, so you make the connection here. And for A minus, so you just take a bigger loop and connect to the right hand side of the direction control for cylinder A. Okay, that is for connecting input 3. Then what you do, input 4. So input 4, we know input 4 must be connected to previous models input 6, not port 6, input 6. So meaning, so you have, so I always start with the second module, because the first module you won't see the previous connection. So if you start with B plus, so you can see port 4 is connected to the previous model's input 6. So this is a previous model's input 6. So similarly here, so the input 4 is connected to previous models input 6. Similar to here, only for this it is connected back to the last sequence. So because this will be going in a circle, so meaning, so once A plus, B plus, B minus, A minus, then it come back to A plus. So the previous sequence of A plus is actually A minus, is in the circle. Okay, so you need to connect port 4 of A plus to port 6 of A minus, so it will be connected. Okay, so you already connected the input 4 for to input 6 of the previous module. Okay, then you move to the next step. So input 1 must be connected to input 5. So input 1 is connected to input 5 of the previous model. So you have, okay, I always start with B plus, okay, or the second sequence. So this is connected to uh, this is input 1 of this B plus model is connected to the previous modules port 5, input 5. Okay, similar to here and similar to here. So only for this, so what happened, where it connected, it is connected to the previous model for A plus is A minus. Okay, so it's connected here. Okay, so you already make the connections. Okay, you already connected the inputs to the previous models input 5. Okay, then this is the last sequence. So you connect input 2 to the input switches or relay switches. Okay, already connected input 3, input 4, input 5, input 6 and also input 1. So remaining is only input 2. So input 2 must be connected to input switches and also roller switches. So for this sequence you have 4 roller switches, A0, A1, B0 and B1. Okay, and also one push button to start. So push button normally you will attach to the first sequence of the circuit. So whichever operation is starting, so you need to put by default push button in the first sequence. So in this case A plus. So you just attach push button to input 2. Okay, then you already settled this. You only have 4 more switches to connect. So you have here 4 AND gate and valve. Okay, so you the possibility of one roller switch to every AND valve. Okay, so you can read here, sequence 1 will activate switch for off sequence 2, meaning what you need to see, when this sequence is executed, which switch will activate. So meaning if A plus, so let's say this cylinder is extending, once it fully extends, which switch will activate? So obviously it will be A1. So A1 you put in the next sequence, because next sequence will be activated, must be activated in order to activate this sequence. Okay, so here B plus, so once cylinder B plus fully extend, it will activate B1. So B1 you put in the next sequence. Okay, once B1 is achieved, this operation B minus, so meaning the cylinder will retract. Once it fully retract, B0 will be activated. So you put B0 in the next sequence. So once B0 is activated, so it will start operation A minus. So A minus meaning cylinder A retract. Once it fully retract, A0 will be activated. So A0 you put in A plus. Okay, so you already put. So finally A0 and B0 will always be in actuated condition. So if you see compared to all the other things, so only A0 and B0 must be in actuated position, meaning this will be in the left hand side, while for this it will be in the right hand side, unactuated. A1 and B1 will be unactuated, A0 and B0 will be actuated, so it will be on the left hand side and you will have a surface here indicating it's always on. Okay, okay, so that's all from me for today. So today I will just recap. We have seen about step counter method for pneumatic and also hydraulic circuit design. So step counter is equally important as cascading method, so which you will be tested in your exam. Okay, so normally in your exam you will have 2 or 3 cylinder application. So I hope you will pay some attention and try to learn from the videos and our discussion session how this step counter method and also cascading method works. Okay, try to do your examples given and also your tutorials in order to get better understanding. So until we see in the next video, take care and bye.